Ever feel like navigating your data is like wandering through a maze of tables? What if I told you there is a way to create your own shortcut, personalized perspective on your data? Let's unlock the power of SQL Views. Hey there and welcome to Guide Coachings. I am your guide Moazzam, and in this tutorial we are going to demystify SQL Views. Think of them as virtual tables built on the foundation of your existing data. They offer a fantastic way to simplify complex queries, enhance securities, and provide a more focused look at the information that truly matters to you. We'll explore what they are, when to use them, the different flavors they come in, how to build and manage them, and even how to make them interact with your underlying tables. So buckle up and let's get started. So these are the topics which we are going to cover in this tutorial. The first is what is a view and when do we use it? That is the most important question. The second is how many types of views. The third is how to create a view. Next is how do we drop a view. The next is how to fetch data from multiple tables and use views, how to add metadata, and last two are the most important, that is how to see schema of a view and how to do schema binding in a view. So let's get started with the burning question first. What is view and when do we use it? A view is a stored query that acts as a virtual table. It doesn't store data itself. Instead, it presents a specific selection of data from one or more underlying tables. Every time you query a view, the underlying query is executed and the result is presented to you. Now, when to use? So there are three conditions where you can use views. The first one is simplifying complex queries. Imagine you frequently need to join multiple tables and apply filters. Instead of writing the entire complex query each time, what you can do, you can create a view that encapsulates this logic. You can query the view as if it were a single table. Then the next important point is security. First we are going to see the first example practically, and then we are going to move to the next one. All right, so here we are on the practical window. Here you can see we have a employees table which has some columns: employee ID, first name, last name, and department ID. Now I am adding these four values. So now we'll see the values of it, and we can see these are the values present inside my employee table, and we'll create a department table. So here in department table, I have only two columns. I'll just create it. Once that is done, I will add these three values inside my department table. Okay, so 3 rows added successfully. Now I will see the result. I will execute this. These are the 3 records present inside my department table. Now I have employee table, I have department table. Now I want to join both the table together and I want to see the result. So for joining a table, we will be using join. So here is a query which we have written without a view. If I want to join a table, we know that we will be writing the column names and we will be prefixing all the column names with the table alias which we are creating. So this is the employees table. The alias is E. First name is coming from the employee table, last name is coming from the employee table, and department name is coming from my department table. Then join and then department name D, and on the basis of what? Department ID, I'm joining these two tables, and where department name is sales. So here are the two employees which are working in the sales department, that is Alice and Charlie. Every time whenever I want to see the records or data from the sales department, I need to execute this query. This is just example. The query can be more difficult, it can be more complex, it can have multiple joins. So this is just a glimpse of it. A query could be difficult to remember, difficult to create every time. So what we can do, we can create a view and then we can put these difficult queries inside the view, and then we can use it. How it makes our life simpler, I'll just show you. What is the syntax of a view? So view syntax is same as table syntax. The way we write create table, table name, similarly we will be writing create view, view name as, and then I will write the query. So if I want to write this complex query inside my view, what I will do, I will be writing over here. This is the place where I will be writing it. Now if I want to delete a view, if I want to drop a view, how I can do? Drop view, view name. Now we'll see the example which we were talking about, and this is how I can drop my view. If I want to create this view, I will just select this view and I will create it. So my view is created successfully. If I execute this without a view, it will going to give me the result. But every time I need to execute this query and every time I need to write or save this query. But if I create a view out of it, I will not require it to remember the query. Okay. Now if I execute it, you can see the same result is coming after executing my view. After doing this experiment, we got to know two things: that it makes the complex query easier to understand and it saves a lot of time. Now assume a situation where you are working in a team and you are a junior developer and the senior developer is developing a query, a huge query with lots of joins and lots of complications. Now if he is going to give you the query, there are chances that you might delete some data, you might add something by mistake. So in that situation, to overcome all these scenarios, what we can do, we can create a view and we can give a view access. The junior developer who is executing the query will be aware about vSales employee. He does not need to understand the difficulty level. He will just simply execute this query and he will get the result. So this was the point of simplifying complex queries. Okay, now let's talk about the security. You can grant user access to specific columns or rows through a view without giving them direct access to the underlying sensitive tables. For example, you might want to allow HR to see employee names and department information, but restrict access to salary details, which resides in employee table. You could create a view that exclude the salary column. So this is how view can help us to secure the sensitive information. Now, the third point is data abstraction and consistency. Views provide a consistent and simplified interface to the database. Even if underlying schema changes, applications querying the view might not need to be modified if the changes are handled within the view definition. Let's go back to the practical window. Over here, you can see this is my complex query. If tomorrow I want to add two more tables into my query and I want to increase the result, increase the search result, and want to get the output. So for that, I don't need my junior developer to understand what I have done logically in the query. He will just execute the query in the same way he was doing earlier and he can get the result. That is the benefit of data abstraction and consistency. You can maintain a consistent query with view to execute and get different type of results. Now let's move on to the next question, that is how many types of views are available. So there are multiple types of views which are available, but the base working is same for all. While the core concept of a view remains the same, there can be categorized based on their characteristics and capabilities. The main types are standard views. These are the most common type. They are created using create view statement and act as a virtual tables based on single select statement. The example we have seen so far fall into this category. Indexed view. Indexed view in some database systems like SQL Server, these are special type of views that are materialized, meaning the result set of the view is physically stored in the database. Similar to the table, this can significantly improve query performance for frequently accessed views. However, they come with overhead for data modification in the base table. Now let's talk about the next type of view, that is partitioned views. In some database systems like SQL servers, these views join horizontally partition data from multiple number tables across one or more servers, making the data appears as if it comes from a single table. Now, the next is system views or a catalog views. These are provided by the database system itself and contains metadata about the database objects such as tables, views, columns, users, etc. You can typically query these to get information about the database structure. Example includes sys.views, sys.tables, information schema.views, etc. Alright, so now let's talk about how to fetch data from multiple tables. Views are incredibly helpful when you need to retrieve data from multiple related tables. You define the necessary join clause with the views select statement as we have seen in the previous example. Now let's move on to the next question for the day, that is how to add metadata and insert, update, delete operations on original table. By default, views are often read only or have limitations when it comes to directly performing data modification operations such as insert, update, delete. However, under certain conditions, you can perform these operations through a view and changes will affect the underlying base tables. Conditions for updatable views. There are certain conditions to create a updatable views. The first one is the view must reference only one base table. In most simple cases, the view must include the primary key column of the table. The view should not contain aggregate functions like sum, average, count, group by clause, or distinct clause. The columns being modified in the view must directly correspond to the column in the base table. Okay, these are certain conditions which you need to fulfill while you are adding, deleting, or updating records inside a view. Now let's move on to the next question, that is how to see the schema of a view. Now here we are on the practical window and you can see I have created insert, update, delete operations on my view. I have excluded the department table for simplicity. Here I am creating a view, create view, view name, and here v underscore is a nomenclature which is used to define a name of a view. Unless if you don't do that, the person who's taking it will consider it as a table, but it is not a table, it's a view. So that is why it is a good practice to do every time whenever you are creating a view, you should write vw or v at least for creation of a view. So over here create view, view name as, and then over here select employee id, first name, last name from employees. So this is how my employee view is going to be created. Now I want to insert values inside my view. So how I will do that? Insert into table name, insert into view name. So insert into view name and then values I will be adding, and then once that is done I will be executing it. So value will be added successfully. I'll just delete this. This is not required. Okay, now if I want to update the similar way we are updating the values inside the table, we are going to use that update view, set the column name, and then we'll set the value and where employee id is 5. And this is how I'm going to do that. Now if I want to delete a particular row, I will write delete from view name and where employee id is 5. So this way the fifth record will be deleted. So I'll just delete this. Now I will check the base value. So I'll just execute it and we'll see in the base table. So here you can see only 4 records are present and the fifth record is deleted successfully. So this is how you can perform insert, update, delete on your view. And remember, while you are adding or deleting any values from the view, you need to remember the conditions which we have spoken earlier. Now let's talk about the next question, that is how to see schema of a view, the internal structure of a view. So you can inspect the structure, column and their data types of view using various methods depending on your database system. Graphical tools. Most database management tools like SQL Server, Management Studio, PG Admin, dbeaver, etc. provides a visual way to see columns of a view in the object explorer. We will be writing execute space sp underscore help text view name. So if you execute it, you can see this is how the query is executed, designed. So you can see over here we are referring to our first example which we have taken, where we have created a sales join table as employees, sales employees. So if you can see the values over here and the structure over here, schema is defined. So if I execute this, I will be able to see the table values, but if I execute this, I will be able to see the schema of the view. See, this is one situation where I am able to see the schema. But if I want to restrict my user to see the schema, what I should do and how I can restrict it. So now question comes, how to do schema binding in a view. Schema binding is a feature that ties a view to the specific schema of its underlying base tables. When you create a view with a schema binding, the table prevents you from making changes to the base table objects, example dropping columns, renaming tables, that would affect the view's definition. This adds a layer of stability and ensures that the view remains valid. And what are the key points? The key points about schema binding is while you are creating the view, you will be writing with schema binding. You must explicitly reference the base table while you are creating with schema binding. You need to write dbo.schema, dbo.employees. Once a view is schema bound, you cannot drop or modify underlying tables in a way that would invalidate the view without first dropping the view itself. Schema binding can sometimes offer slight performance benefits as the database has more information about the dependencies. Now we'll see how schema binding a view is created. So create view, view name, and then with schema binding as, and I am using the same example over here. Now if I execute this, the view is created successfully. I just will execute it, so I am able to see the records. All right, that's all for today. In the next session, we are going to answer two most important questions. That is, the first is, when you update your base table, is the data which is added, deleted, or updated inside your base table is reflecting in your view or not? Then the second is how you can restrict a user to delete, update, or insert a record inside your base table while you are using it for view. That's all for today. Thank you.